So in the previous few videos, we have already talked about definition and value of a function, interval, etc., then domain, range, and various standard functions, algebra of functions. Now we move on to a few more serious topics. So starting with classification of functions. In the series of videos, this is what we are going to talk about. So start with the first part, which is a one-one function. So as we are already familiar with functions, let's just take a look at some arrow diagrams. So look at these two, right? We write y equals to fx and y is the image of element x under f. So for a function, we have talked about the uniqueness and existence of pre-images. So these are the things that we already know. Now look at the reverse thing. X is called the pre-image of the element y under f. Now let's talk about pre-images. So the arrow diagram, if you look at them, one has three pre-images, whereas here one does not have any pre-image at all. So we can definitely talk about their existence and uniqueness. And if we talk about them, we will get some special type of functions. So this is where the origin of classification of function starts. So let's get started. In this video, I'm basically going to talk to you about one function, which is one classification of function. So what does it mean? Look at the name again, 1, 1. So definitely it's 1, 1 or injective if different elements of A have different images. So if you have two different elements, they cannot have the same image. So this is what it talks about. Alternatively, we write if there are two functional values which are equal, then the original inputs, they have to be equal. Now you can understand that this comes from the uniqueness of pre-images. This part is very important because we use this alternate definition to sometimes prove the injectivity. So let's see some examples. Start with the most basic arrow diagrams. This is actually problematic because A and B are not equal, but their image is equal. So no, this is perfectly all right because you can see that different elements have different images. Again, if you look at this one, this is perfectly okay. Whereas for this one, A and B are different, but their image is the same, which is 2. So this is problematic. So we are not saying that it's a 1, 1 function. Apart from all these arrow diagrams, it's very important that you people also see some general things, okay? So we have to check whether the function is 1, 1 or not. The function is from n to n and it's given by fn equals to 2n plus 3. So let's check whether it's 1, 1 or not. The first thing that comes to our mind is how do we check for general things? Now, when we were talking about the definition and mathematical alternatives of the definitions, I talked to you about the second alternative that we used, which are very, very important. So this is what we start with. We take two outputs which are same. We are going to show that the original input is the same. So let's explore the definition of the function. Now some algebraic manipulations and we are done with this. So definitely this is a 1, 1 function. Let's take another example. So we have taken f from R to R defined by fx equals to x minus 1, x minus 2, x minus 3. Problem is if you put x equals to 1, the output will be 0. And if you put x equals to 2, the output will be 0 as well. So you can actually have two equal outputs even if the original input was not equal. So definitely it's not going to be 1, 1. So I hope you understand the reason behind the classification, why all of a sudden we had to make separate cases. And also this was the first one. In the next one, building up from this concept, I'm going to talk to you about many one functions. So stay tuned.